Hello, class. This is Mr. Hart. In this podcast, we want to look at the next part of the forces unit, and specifically looking more at vectors and their components. Okay, and very specifically, we want to be able to mathematically represent these now, rather than just drawing them. Okay, so last time we focused a lot on how to visualize vectors and how to draw them and add them using the tip-to-tail method. But that's not a very convenient way to do it, especially if we're doing a lot of these problems and we don't have a lot of paper and a ruler and a protractor, right, to do these all the time. So we need a mathematical way to describe these and get these values more quickly. Okay, and we're going to have to go back to our algebra and geometry classes and go back to the Pythagorean theorem. Okay, so when we're trying to add vectors analytically, or basically just mathematically, we're going to need to know the Pythagorean theorem. Because, for example, let's say we have a vector that's up 7 miles to the north and another vector that's 10 miles to the east. Well, you'll notice that this is just a right triangle, right? These two vectors added together just makes this right triangle. So the resulting vector is just the hypotenuse of that right triangle. So all we got to do is use the Pythagorean theorem to find the hypotenuse, right? So we'll take 7 squared plus 10 squared to give us c squared, which is the resultant, okay? And that should give us 12.2 miles, okay, after all is said and done. And so this is the hard thing about vectors for my class, is I don't have the time to go through and reteach everything you need to know about triangles and right triangles, and some of the stuff you may not even have seen yet with trigonometric values, okay? And so I'm going to show you some equations that are going to help us do this, but I can't really take the time to explain why they work. You'll need to go to your math teacher, and when you get to these units in math class, then you'll have the time to kind of fully understand why these work. But for now, you're going to just have to accept what I say, basically, on my word. Okay? So these are the two equations we're going to need to know. Okay? And I highly recommend writing these down. So the resultant vector, which we'll just call capital A, is equal to the x component, or the x vector, plus the y component of the vector, okay, squared, all square rooted. Okay? This should look familiar because it's just a rewriting of Pythagorean theorem. Okay? If we say that a squared plus b squared equals c squared, right, then I can square root both sides, and c squared square rooted just gives me c, right? So c equals a squared plus b squared. Well, that's exactly what we just stated up here. Okay? And so all it is saying we're using the Pythagorean theorem to figure out how long the vector is. Okay? So how long the vector is, a, is equal to the square root of x squared plus y squared. Okay? And that's it. Not too bad. All right, this one comes from trigonometric values, and again, this is one if you haven't had all of secondary 2 yet, or even maybe in secondary 3, this won't make much sense yet. But let me just try and explain the best I can. This symbol right here is called theta. It's a Greek letter, and it represents the angle. Okay, so if you ever see theta in math and physics, everyone pretty much has agreed upon to use theta only to represent angles. Okay, so the angle is equal to a special function which we call tangent inverse, okay, of the y vector over the x vector. Okay, so on your calculator, if you have like a TI 84 or a TI 30, if you pull your calculator up, there's a button right here that says tan, okay, and tan is tangent, which is the function we're using. But we don't want to just use tan, we want to use the inverse of tangent. And so you'll notice in blue, right above it, is the tangent inverse button. So on your calculator, what you're going to have to do is you're going to have to press the second button, and then you'll press the tangent button. And that should give you the tangent inverse on the screen. Okay? So tangent inverse is what we're trying to get. Now, again, you just put y over x, and it should give you the value you need. So let's say the y is 5, and the x is 4, like that. Then it should tell you your angle in degrees. So that's about, let's see, 51 degrees. Okay? So if I had a y of 5 and an x of 4, that would be the angle that it makes to them. Okay. Now, please be careful on your calculator. You need to make sure it's in degrees mode. And this is kind of a pain because in math you do a lot of problems in radians. In physics we do all our problems in degrees. And so just be careful when you do that in math class or physics class. You want to make sure your calculator is on the right mode. I took a physics test once with my calculator in radians the whole time and didn't realize it, and I missed a ton of questions because it wasn't in the right mode. So to do that, on the TI-84 at least, you're just going to click this mode button right here, okay? And then right at the, let's see, right here, third line down, you can choose if you want it in radians or you can choose if you want it in degrees, okay? So just make sure you have degrees selected. Some calculators have a separate button for it. Whatever it is, just make sure you're on degrees before you try and do these types of problems, okay? And so that's kind of the setup. I know it may not make a whole lot of sense what this is actually doing, but again, we have to save that for math class, okay? So let's just look at an example problem, and I think this will kind of clarify what we're trying to do. Okay, so let's say we have these two vectors, 4 meters to the east and 3 meters to the north, and we're trying to find what the total displacement is, okay? Well, first of all, if we visualize, right, this vector is going to look something like this, right? It's going to be the hypotenuse of that triangle. And so if we're trying to find the length of that, well, we're just going to plug it into the Pythagorean theorem, right? So the length of the vector is just the square root of the x component squared plus the y component squared. In this case, that's the square root of 4 squared plus 3 squared. And if you put that into your calculator, 4 squared plus 3 squared, don't forget to square root. A lot of students forget that. All of that square rooted, you should get 5 meters. Okay? So this resulting vector is 5 meters in displacement. And then we're wanting to find the angle right here, right? Which again we call theta. We want to figure out that angle the vector's making. So what we're going to do is we'll just say tangent inverse of y over x, or 3 over 4. And that should be equal to, again, on your calculator, make sure you do the tangent inverse, so second tangent. Okay, so second tangent is the tangent inverse of 3 over 4. And we get that it's about 36.8 or so. Let's just round to 36.9. So about 36.9 degrees. Okay? And there we go. So that's this angle right here. The angle that this triangle is making, or this vector is making, is 36.9 degrees. Okay? And by convention, we always reference to the x-axis, okay, or to the east, however you want to think of it. Okay? So this angle right here is 36.9 degrees. Okay? There we go. And that's all there is to it. So again, you're just going to have to memorize these two functions, or at least know how to use them. You can write them on your paper if you want, but you're going to need to know how to use these two functions. You may not necessarily need to understand how they work right now. Okay? Alrighty. Another thing to be careful of really quickly is be careful of the word displacement versus the word distance. Okay? If you see the word distance, again, that just means total path traveled. So in this case, the total distance is 7 meters, right? 4 plus 3. So be careful if it means it wants the vector addition or the just scalar addition of all the different paths. All right, let's do one more problem just to practice. Okay, so we have these two vectors, 7 meters and 3 meters. And we're trying again to find the resultant. So that's going to be this vector right here. So if we're trying to find the length, we just plug it into the Pythagorean theorem. So we're going to take the square root of 3 squared plus 7 squared. Put that in our calculator. 3 squared plus 7 squared. Don't forget the square root. You should get that the total length of the vector is 7.6 meters about. Okay, so that's 7.6 meters. And then we'll do the tangent inverse of 3 over 7. Okay. And we get that the tangent, sorry, let me write this down. Tangent inverse of 3, which is y, over 7, is 23 23.2 degrees. Okay? Now, this is where you need to be careful, okay? Because, like I said, by convention, we always reference from the x-axis. So a lot of students will say, oh, this angle right here is 23.2 degrees, okay? But that's wrong, okay? That's not the case. That is not the angle we just found by using the tangent inverse. What we just found was the angle in reference to the x-axis, right? Or to the west or to the east, however you want to say it. Okay? So in reality, 23.2 degrees is this angle right here. Okay? That's the angle we just found. Okay, not that inside angle, we found this angle. Okay, so you just got to be careful and make sure you're describing properly what you're finding. Okay? Alrighty. But there we go. That's it. So again, you're just kind of using those two equations to find the values you need. Okay? Alrighty, let's move on. So sometimes you may not be given the components of a vector. You may not be given the things that make it up. You may just be given the total vector. So if you're given a magnitude and a direction, or basically just the resulting vector, it may sometimes be helpful to find the original components that made the vector up. And again, we can do this by using some simple trigonometric functions. Okay? And again, I don't have the time to go through the math of why they work. I just can show you how to use them. Okay? So here are our two functions. Okay? So the x component of the vector is equal to the magnitude of the vector times the cosine of the angle that you get. And the y component of the vector is equal to the magnitude times the sine of the angle that you get. Okay? So again, if you haven't seen sine and cosine before, it's not sin and cos. Okay? There's sine and cosine. These are functions on your calculator you can use. And again, you're just going to use the angle in degrees. Okay? So going back to our calculator, if you look right here, you got the three trigonometric functions right next to each other. So you got sine, cosine, and tangent all right next to each other. Okay? So in this case, we're not using the inverse. We're just using the regular version. So you just have to press it. You don't have to press second. Okay? And you'll just times whatever you get to the magnitude of the vector to get the result. Okay? So again, let's try an example problem. And this will make a little bit more sense. And again, I don't have a lot of time to explain why it works, but we can see how we can get the different components. Okay. So here's our example problem. We have 8.2 meters as our vector length at a 40-degree angle from the x-axis. Okay? So what we want to do is we want to break this into its original components. I'll draw those in yellow. So we want to find this vector in the x direction and this vector in the y direction that originally made it up. Okay? So to get this y component, again, it was y equals the sine, or sorry, let me write it this way. The magnitude of the vector times the sine of the angle, and that is going to be equal to, that's going to be equal to 8.2, that's the distance or the magnitude, times the sine of 40 degrees. So we're going to pull out our calculator, plug in 8.2, right? And then we're going to times that by, again, going up here, we're going to look for the sine function. Okay, so I'm just going to put sine of 40 degrees. Okay, again, make sure my calculator is in degree mode, and it should look like that. And then if I press enter, okay, I should get the result of 5.27 meters. Okay, so that's what we're trying to do. So y right here is equal to 5.27 meters in length, and x is the same thing, but instead of using sine, we do a times cosine of the angle, okay, which is 8.2 times cosine of 40. Okay, so same thing, 8.2 times now the cosine function on the calculator of 40 gives us that x is equal to 6.28 meters. Okay, so there we go. So the original vectors that made this up with the original components was x in 6.28 meters in the east direction and y 5.27 meters up. Okay, that made an 8.2 meter at a 40-degree angle vector. Okay, and there we go. All right, so again, there's a lot of functions in this. Basically, either you're given the components and you need to find the resulting vector using these two equations, or you're given the magnitude and the direction and you have to find the two components using these two equations. Okay, so you make sure you know when to use which one. Okay, and that's pretty much it for the homework. Let me show you one more thing you may need to know how to do, and that's how to add vectors, okay, analytically. Okay, so if you're adding vectors, it's really easy if you just simply add the components together. So basically you can add the x values and the y values together to get the resulting vector. Okay, so for example, if I have a sub x, or the x component of the vector a is 4.5, a sub y is -3, and I have another vector b, which has an x component of -5.5 and a y component of 7, if I'm trying to find a plus b, okay, it's really easy. I just add the x and y components together. So x plus x would give me an x of -1, and y plus y will give me a value of 4. And that's it. So a plus b, this new resulting vector, has a length in the x direction of -1 and a length of 4 in the y direction. That's it. Okay? And then from there we can do what we did before to find the magnitude and the direction. But to add vectors is really easy if you just have the components. Okay? And that's pretty much it. So there you go. That's your homework. Just a lot of different types of problems this way. Again, you're either given a vector and its magnitude and its direction, or you're given its components, and you just have to be able to switch back and forth between them. Okay? This will become very helpful when we move into forces. Okay, so I'll make sure you get this homework down. But that's pretty much it. Let me know if you have any questions, and thank you for watching.